If your lookup formula looks correct, but still returns #AA, the problem is often invisible. It's usually extra spaces hiding inside your text. That can happen when data is copied from emails, PDFs, web pages, or exported systems. To you, Acme and Acme look identical. To a lookup, they are different values, so the match fails. In this video, you'll learn a reliable way to diagnose space problems, clean the source text, and make lookups behave consistently. We'll focus on the clean function, and also when clean is not enough by itself. You'll leave with a simple workflow: detect, clean, retest, and lock it in. And you'll understand why some spaces are normal, some are non-printing, and some are just stubborn. Once you fix this, your VLOOKUP, XLOOKUP, match, and index formulas become far more dependable. Let's start by understanding what extra spaces really means in spreadsheet terms. Next step. A lookup works by comparing one value to another, character by character. That means a single extra character breaks a match. The most common culprit is a trailing space at the end of a name or code. Leading spaces at the start are also common, especially after imports. Then there are double spaces in the middle, like New York, with 2 spaces. Those are harder to notice because the text still looks fine at a glance. Another category is non-breaking spaces, often coming from web content. They look like normal spaces, but behave differently. And finally, there are non-printing characters like line breaks, tabs, or odd control codes. These can sit inside a cell and ruin a match even if you can't see them. The key idea is simple. Lookups don't match meaning. They match exact text. So your job is to make the text identical on both sides. Next, we'll quickly confirm when spaces are the real reason your lookup fails. Next step. Before you start cleaning everything, confirm the issue. A fast test is to compare the apparent length of 2 values that should match. If one is longer, something extra is in there. You can also check whether a value equals itself after cleaning. For example, if a cleaned version differs, you've found hidden characters. Another practical test is to copy the bad value into a plain text editor and look for weird spacing or line breaks. But inside a spreadsheet, the most useful mindset is measure first, then fix. That keeps you from accidentally changing valid data. Also note that some IDs legitimately contain spaces, like formatted account numbers. In those cases, you don't want to remove all spaces, only the invisible junk. So the goal is not make it pretty. The goal is make it consistent. Next, we'll talk about what clean actually removes and why it's a good first step for lookup reliability. Next step. Clean is designed to remove non-printing characters from text. Think of characters like cabs, carriage returns, and other control codes that can sneak in during imports. These characters are not the same as regular spaces. That's important because it means clean won't fix every space problem by itself. But it's still a great first pass, because non-printing characters are a common reason a lookup fails even when trim seems to do nothing. A typical use is simple. You wrap your lookup key with clean, or you create a clean helper column and reference that. A helper column is often safer because you can compare original and cleaned values and confirm what changed. Clean also helps when your data includes line breaks inside a cell, which can happen when someone presses Alt-Enter or when a system exports multi-line fields. Once those are removed, your text becomes a single consistent string again. Next, we'll combine clean with trim, because most real-world datasets need both. Next step. If you only remember one pattern, make it this. Trim of clean. Clean removes the hidden control characters. Then trim fixes spacing you can't trust. Trim removes leading and trailing spaces, and it also collapses multiple spaces in the middle down to a single space. That solves the classic, it looks the same mismatch. The order matters in practice. If you trim first, some non-printing characters can remain and still break matches. So start with clean, then trim. In a helper column, you'd create a cleaned key like trim clean original. Then use that cleaned key in your lookup, or clean both the lookup value and the lookup table key. Cleaning only one side can still fail if the other side contains junk. Also be careful with product codes where internal spaces are meaningful. Trim will collapse doubles to singles, which is usually fine, but it can change intentionally spaced formatting. When in doubt, test on a small sample first. Next, we'll apply this to common lookup formulas without making them fragile. Next step. There are two clean ways to implement this in your lookups. Option 1 is a helper column in your data table that stores the cleaned key. That keeps your lookup formulas readable and fast. You clean the key once, then reuse it everywhere. Option 2 is to wrap the lookup value directly inside the formula. That's quicker to set up, but it can get messy and harder to audit later. For example, with XLOOKUP, you can clean the lookup value and the lookup array key column. With VLOOKUP, you typically clean the first column of the table in a helper column, because VLOOKUP expects the key to be the leftmost column. With match and index, you have more flexibility, but the same rule applies. Compare clean to cleaned. The most important habit is consistency. Decide what clean means for your dataset, apply it the same way everywhere, and your lookups stop randomly breaking. Next, we'll cover a tricky case. Non-breaking spaces that trim may not remove the way you expect. Next step. Sometimes you run trim and clean and the lookup still fails. A common reason is the non-breaking space, often inserted from web pages or HTML exports. It looks like a normal space, but it's a different character code. Trim may not remove it, and it can sit at the start, end, or even inside the text. The practical fix is to convert that special space into a normal space, then run trim again. In spreadsheet terms, you use a replace step before trimming. This is why a cleaning pipeline mindset helps. First remove control characters, then normalize spaces, then trim. If you work with data copied from browsers, CRM systems, or online reports, this comes up a lot. The good news is that once you normalize the space character, your standard trim-clean approach starts working again. Next, we'll talk about building a repeatable cleaning column you can trust, and how to validate that it's actually fixing your match rate. Next step. A reliable workflow is to create a dedicated clean key column next to your original key. In that column, apply your cleaning pipeline consistently. Start with clean to remove non-printing characters. Then normalize unusual spaces if your sources include web content. Then trim to remove leading and trailing spaces and collapse doubles. After that, validate with two quick checks. First, compare the length of original versus cleaned to confirm something changed where you expected it. Second, test a lookup using the clean key and see if the Nash NA rate drops. If you're cleaning both the lookup input and the table key, you should see matches recover immediately. Also, keep the original column. It's your audit trail, and it prevents you from losing information if a space was meaningful. Once you trust the clean key, you can base all downstream logic on it. Lookups, joins, deduping, and even pivot grouping. Next, we'll cover edge cases where cleaning can change meaning and how to avoid breaking legitimate formatting. Next step. Cleaning is powerful, but it can also change data in ways you didn't intend. The biggest risk is when spaces are part of the true identifier. Some organizations format IDs with internal spacing, and collapsing multiple spaces could hide meaningful differences. Another risk is leading zeros, which often get lost when text turns into numbers. Clean and trim won't remove zeros, but the act of re-importing or reformatting might. So treat keys as text and keep formatting consistent. Also watch out for case sensitivity. Most spreadsheet lookups are case insensitive, but some comparison methods are not. If your system treats ABC and ABC as different, you may need a case normalization step too. Finally, remember that clean targets non-printing characters, but it won't fix misspellings or different naming conventions. It's not a data standardization tool. It's a text hygiene tool. Next, we'll finish with a simple checklist you can use anytime a lookup fails for no reason. Next step. Here's a quick checklist you can run whenever a lookup fails unexpectedly. First, confirm the values truly should match and compare their lengths. Second, create a clean key using clean, then trim and normalize special spaces if needed. Third, make sure you clean both sides of the comparison, not just the lookup input. Fourth, retest the lookup using the clean key and confirm the match behavior is stable across multiple examples. Fifth, keep the original data column so you can trace back what changed. Once you start using this approach, you'll notice a pattern. Most mystery lookup errors are just text inconsistencies. And the fix is rarely a more complex formula. It's cleaner data. If you want, you can standardize this into your import process so the cleaning happens before analysis even begins. One small habit saves a lot of debugging time later. If you found this helpful, subscribe for more practical spreadsheet fixes. And comment with A or B. Do your lookup failures come more from trailing spaces or from weird non-printing characters? I'm always testing new ways to work smarter. Subscribe to see what workflow I'm breaking down next.